and welcome to tutorial sheet 1, question 4. So for question 4 we will only do part A, just to demonstrate to you. As with most of the tutorial sheets, you'll see that the answers are already given, and this is just to instruct you as how we get there. So for question 4, it's very similar to question 2 in that you have to find a resultant and so a magnitude of a force vector as well as the direction of it. The key here is equilibrium, so what is meant by this question here. So in previous ones you're given a number of force vectors and find the resultant. So if we pretend this is a soccer ball, it's going to have a resultant force vector in some direction. So that means that this ball is going to go off in one particular direction. Its force is going to be applied in a certain direction. However, when we say equilibrium, what they're asking you to do in this question is, if we were to apply, in this case, a fourth force vector to counteract the resultant to ensure that this ball is in equilibrium, i.e. is not moving. So we want to make sure it is at rest. So that means that a fourth vector needs to be applied, but the question is where and how much. So to do that, you need to find out what the resultant is of all these three forces. And once you find that, you want to put an equal but opposite force vector, which will then mean that this series of force vectors on this ball will become balanced, so it won't move. So it follows the same steps so as question 3, in that you find your resultant either through trigonometrical or graphical methods, find the resultant and then apply an equal but opposite. So as always, you just want to follow these steps and it'll make things just that little bit easier. So as always, step one is to set axes. So as always, the horizontal to the right is the positive x and the vertical going upwards is the positive y. So in step 2, we'll use trig in this method here. You want to delineate the two types of forces in the x and y, just to make life easier, because we don't have any of the forces going along the x or y direction. So all of these will, actually the 40 newtons is going in the negative y, so that's easy. So the 30 newton has both an x and a y component, and the 50 newton has an x, a negative x and positive y component. Alright, so we need to follow those. So we will start off with the forces, which we'll just call F, that are in the x. Alright, so the 40 newton force vector is not going in the x, so it doesn't have component. So we'll start off with the 30 newton, and it is 30 times cos, because it's the adjacent, 45. So that is all positive because it's going in the positive x direction. So for the 50 newton, its x component is going in the negative, so it's going to be negative 50 times, in this case, so if this is 90 degrees, so what's left here, so it's 90 plus 45, and that is 180 minus that, so it's 45. So, and that's going to be, again, cos 45. So you're asking, where did I get that 45? I'm using this angle here, so and that's going to be 45. So 45 is 90, plus 90 gives you the 180. And they're the only x components in this. So cos 45 is 0.71-ish. So cos, just to show you here, cos 45, and that is times 30. So that is positive 21.21 newtons minus 35.35. 35.35 That equals 14 negative 14.14 newtons in the x. So now let's look at the y components. So what are our y components? So all three force vectors have y components. So the 40 is going in the negative direction. It's the easiest. So the good thing about 45 degrees and what makes it easier is sine 45 is the same as cos 45, which is 0.707, I believe. So it's going to be the exact same values as the x component, but you just make sure of your negative and positive directions. And it's easy because the y component of both the 30 and 50 are in the positive positive y direction, so they're both going to be positive. So it's plus 21.21 plus 35.35. Alright, so that is 35.35 plus 21.21 minus 40 equals 16 so positive 16.56 newtons in the y. So now we have the x and y component of our resultant. Alright, so step 3 then is to find the resultant using Pythagoras. So step 3 is Pythagoras. I spell it right. Okay, so you also get a good idea of the direction after the fact, but we'll just quickly use Pythagoras. So our resultant, which we'll call r squared, equals, so it's 14.14 squared. You can leave the negative in, but it'll just go to a positive, and 16.56 squared. Okay. So that leaves us with just do it here. So 14.14 squared is 199.99. So this equals, let's get the colors back, 199.94, let's say, just rounding it up, plus 274.23. Alright, so bring the square over and become square root. So r equals the square root of the sum of these two guys here. That's 199.4. So we get 474.17 stuff. And that leaves us with an R equals 21.77 newtons. So that is the magnitude of the resultant of these three forces when they're added together. So that's the magnitude. We still don't know the direction. So let's get the direction. So step 4 is the direction. Now, as I said, it's always good to just get a rough idea of what quadrant it is in, so that can easily be done. So we'll just give a rough axes here. Okay, so we know that it is a negative x direction, so we're going to be in the negative x in this way. So it's 14. And we know we're going to have a positive y though, so positive y just a little bit longer. So we know that our resultant is going to be look like this. So resultant in black. So this r of 21.77 is in this direction. So we can use this angle here, which we'll call alpha, but realistically you present it looking for beta. As always, alpha plus beta equals 180 degrees. So we know the x direction is 14.14 newtons, and we know the y is positive 16.56 newtons. So we'll just use cos of the angle alpha, because it's this angle here with this triangle. It's going to be cos equals the adjacent, which is 14.14, over the hypotenuse, which is the resultant R magnitude 21.77. So alpha equals cos to the minus 1 of this. It's 14.14 divided by 21.77. So 0.6495. Don't need to be that accurate. So cos to the minus 1 of that equals 49.5 degrees. So alpha equals 49.5 degrees. But we're not done yet. Now here's a mistake that people always make. So you'll recognize that alpha as the answer that is given in the tutorial. So if we scroll up here, yes, see, now you're wondering negative 49.5, but I have a positive 49.5 here, and this is really important to know. You could stop here and say that this is it, and then you'll lose marks because I know that you don't know what is happening here. So alpha is just this for the resultant of the three vectors that you were given. We truly want beta first, so if you say, okay, beta, which is the angle of this resultant with respect to the positive x-axis, then I know that you know what you're talking about. But that's not the question that was given, right? The question that was given is the equilibrium. So beta equals, this case, so 180 minus 49.5, because it is the substituting it into this equation here. Beta equals 180 minus alpha. So you get beta to be 130.5 from the positive x-axis. Okay, so that is the direction that you should present to me if you're getting the resultant. So this resultant, this beta, is 130.5 degrees from the positive x-axis. But I'm asking, and step 5, which is the added part for when you're looking for equilibrium, is the equal but opposite of this resultant. So if we go back up here to the question and try to visualize what's going on here. So what this question is asking us is, well, this soccer ball here in the center, if it's left to its devices, it's going to go off, and there's going to be a force applied that's going to be approximately this direction here, and it's going to be 21 newtons approximately. Alright, so it means the soccer ball is going to go off in this direction. We don't want that to happen. So what do? Well, you're going to apply a force vector that is equal but opposite to this resultant. So you're going to apply, you know, the magnitude is going to be 21 point whatever we found, 77, so approximately 8 newtons. Alright, it's going to be equal but opposite to this. And now what you need to do is you need to find out what is this angle that is equal but opposite, right? So that's what we're going to find out, and it's typically going to use this trig here. So you know, we already know alpha to be 49.5, and that means that it's going to be, this angle here is going to be 49.5 degrees as well. Now we're not done yet, because you'll notice that it's a negative, and you might ask why. So in the lecture, when we talk about the different quadrants, it's really important to know what they mean. So equal but opposite. So that means the answer, so instead of the resultant being R, we'll call it E, right? E for equilibrium. So E, the resultant of this extra, or so this, the name of the force vector that is going to be opposing to R, so that's in equilibrium E, we know the magnitude is going to be 21.77 newtons, or 8 newtons, 21.8 newtons, doesn't matter. So we already have the magnitude that is done. So you present it to me like this. Don't just assume that I know that you know what you're talking about. Write down that this is the force vector that will achieve equilibrium. Okay, so in an exam setting. Now you need to show me what this angle is. So this is what it's going to look like. And I want you to actually draw it like this, so that this is E. Call this E. So that I know that this is the equilibrium, and that equals 21.7. So if you're asked an exam, I want you to do and draw it like this just quickly so I know. Now what you're going to do is you're going to present to me also this angle. So, and you're going to say, okay, we can call this, because we already use alpha and beta, we're going to call this theta. So what is theta? It's going to be the same as alpha. So great. So theta equals, and this is the key. You can either present it like this. So if you're saying from the positive x-axis, and this is important, the question will ask you for the positive x-axis. Oh, don't want that. So if you were to start here, and work all the way back, right, you can present it to me like that. So it's going to be in a positive degrees. Right, so theta can be presented equal. So it's going to be positive. So 360 minus 49.5. It's going to be positive 310.5 degrees. So you're saying, well, the answer says minus 49.5. Well, that is important, because you can present it like that, because there is, if you go this way from the positive x-axis, you can say, because it's still the positive x-axis, negative 49.5, and it'll be the same thing. It's just what's important is whether it is positive or negative. All right. So if we're going clockwise, in this case, it is positive, and if you're going counterclockwise, it is negative. So basically these mean the exact same thing. Okay. And that's why the question says negative 49.5 degrees. And that's, so either answer is correct, but don't forget, you must say from the positive x-axis. Because without that, then I'm just assuming that you're just guessing and your guess was correct. So you won't get full marks. So make sure that you know. So that'd be the answer. This would be the final answer. Call it E equals 21.77 newtons, or whatever you want to call your force factor. Thank you very much.